Okay, so previously we used the critical value as well as the test statistic to determine the outcome of our test. Now what we're going to do is we're going to use another value to help us to determine the result of the test. This is what we call the p-value. Okay, so let's go back to the previous example that we were looking at, where my H0 is mu equals to 75 and my H1 is still a right tail test. Okay, what we're going to do now is previously x follows a normal distribution, so therefore x bar follows a normal distribution as well, right? So what we're going to do here is we're going to calculate the probability that x bar is more than the sample mean. Okay, we're going to calculate this probability. So I can use my norm the function norm CDF in your calculator with the mean and variance given to calculate the probability. Okay, so what does this probability mean? This probability means that if the population mean is 75, which is what my H0 is saying, then out of 100 tests that we conduct, what is 100? 100 is my sample size. Okay, we will expect a percentage of 0.695 that the mean mass is more than 77.2. Okay, and this probability is what we call the p-value. So if you look at the definition in the box here, this definition is important. You need to memorize this definition. Okay, so the definition of the p-value is the smallest level of significance at which your H0 will be rejected. Okay, assuming that your H0 is true. Alright, so you need to remember the definition of this p-value. Alternatively, you can remember it as the probability that the sample mean is as extreme or more extreme than the sample mean value that was collected, assuming that H0 is true. So over here, we always assume that H0 is true first. Okay, now then what you need to do is when you are regurgitating this, you need to make sure you answer according to the context of the question. So you see the H0 here, right? You need to not write it as H0, but then to write it as according to the context of the question. Okay, so using the p-value, we can actually come up with our test result. So let us see how we can actually do that. Okay, so let us take a look at the example that we had previously. So using a 5% significance level, and our p-value was 0.00695, right? So if you do a comparison, this value is actually smaller than the significance level. What does this mean on diagram? Okay, so if you look at the diagram that you have here, the critical region is on the right hand side. Okay, critical region is the blue color region. It's on the right hand side because we are doing a right tail test. Alright, so the blue color region here, this is your critical region or your rejection region. Okay, the p-value that you have obtained is a probability. Probability is an area. Where is this area? Okay, based on the test statistic, because your p-value is calculated using the test statistic. Alright, this area is smaller, right? So clearly it has to be inside the blue region. So it's actually the black region here. Okay, so this black region is your p-value. So if your black region is inside the blue region, clearly is lying inside the rejection region, therefore we will reject H0. Okay, so similarly, if I'm doing a left tail test, same idea. If my p-value, which is the black region, is lying inside my critical region. Okay, remember that your significance level gives you the critical or the rejection region. So of course, if I'm lying inside, I will reject H0. The same goes for a two-tailed test. Okay, so same thing, the blue regions are your critical regions, and the black regions are the p-value that you have obtained based on the test statistic that you have found. So again, as you can see from the diagram, if your p-value lies in the critical region, clearly we will reject H0. So based on the three diagrams that you have seen, okay, we have come to the conclusion on how to reject or how to come to a conclusion for your hypothesis test. So the criteria is this. We will reject H0 if the p-value that you have found is less than or equal to the significance level. However, we will not reject H0 if the p-value is otherwise, meaning if your p-value is more than alpha. So you will see that in fact, this approach is actually much easier if all your values are known. Okay, meaning your x bar, your mu naught, sigma square, and n, or if you don't have sigma square, you have s square. Okay, with all these values given to you, please use the p-value approach because it is much clearer and easier to help you to come to a conclusion for the hypothesis test. Okay.